Hello, good evening. It is an evening webinar this evening. We're very used to our lunchtime webinars, but I'd like to welcome you all this evening from wherever you're joining us. A little bit about us first before I go through the admin. My name is Sylvia Howes and I'm from Data for Good. And Data for Good is a not-for-profit organisation, and our mission is to inspire and enable people with access to data or who have data skills to use these to benefit humanity and the world. Basically, connecting the right people with the right data to tackle global issues. One of our key impact areas involves assisting not-for-profits with their data projects by providing free data experts. So if you know any projects that could benefit from this help, then please contact us. A quick bit of admin, we will be presenting this in a webinar format, which means your videos and microphones are off, so we can't see you. But if you have any questions, then please type them in the Q&A box, because we do want to make sure that we address those questions, and we do want to make sure that anything that crops up for you, that we're able to address that. So the Q&A box is in the bottom of your screen. Type them as Catriona's presenting, and we'll address them after Catriona's finished with her slides. We will be sending out an email with the resources that Catriona mentions in the next few days, along with a link to the recording. So she will be mentioning a few things. You might be hurrying, trying to write them all down. Don't stress, we will be sending out links to all of those. We have live captioning turned on for this event. You should be able to see a CC Live transcript button on the bottom right of your menu bar. Now, it may show up automatically, or if not, then click on that CC Live transcript button and follow the instructions. And you can change the caption sizing in the accessibility section of the menu. Any issues with that or anything else as the webinar goes along, then please just type them in the chat box, and Samantha, who's our host behind the scenes, can assist. And she can also post in the chat box about the live captioning. So with all the admin out of the way, I'd like to say welcome to our webinar on teaching teachers, getting confident to start teaching AI. I'm joining from the lands of the Wongal clan of the Eora Nation, and my behind the scenes host, Samantha, is joining from the Darawal clan of the Eora Nation. For this webinar, we'll be joining together from many different lands, many different countries, and I'd like to acknowledge the traditional custodians of the various lands which we are gathering from, and particularly the Aboriginal Torres Strait Islander people who are amongst us today and attending this webinar. So kia ora and welcome. I'd like to pay my respects and gratitude to the elders past across the lands who guided and nursed country for many years. We pay our respects to their present elders who continue to provide guidance that we can all learn from. And we pay our respects to emerging community elders. And a special shout out to our Indigenous Next Gen and teachers supporting them on their life journey. Now, speaking of Next Gen, an area we've been developing this year at Data for Good is inspiring the next gen of AI ML data enthusiasts. Now, when I was growing up, this part's never changed, but I loved animals and the environment and different cultures, but my brain was more a technical analytical one, and I went down the tech path, not realizing I could combine these worlds. I remember playing Pod on the computer in the 80s, if you remember that, where you tell an apple some very basic commands and it jumps around and does all sorts of things. And then I remember learning Paint and drawing boxes and auto-filling them so that with varying colors, and then being thrilled to discover you could morph faces from one to another. Now, when kids get excited about learning, it impacts the choices they make. So we want to make it easy to encourage kids into data and encourage them with the idea that they can combine their passion and skills. Now, earlier this year, we were lucky enough to meet Catriona at the STEM Mad Showcase, which encourages students to use STEM to make a difference in the world. Catriona is an innovative and experienced STEM leader with a demonstrated commitment, expertise, and passion for the integration of established and emerging technologies across all primary school year levels. Drawing upon real-world industry experience, Catriona is dedicated to facilitating and promoting STEM literacy through developing transferable skills, habits, and capabilities essential to connect with life outside the classroom. She's passionate about building skills for success in a rapidly changing world. And I think we can all agree it is an incredibly rapidly changing world. She's an experienced curator and designer of STEM units across all primary school levels, with an emphasis on digital technologies, engineering, mathematics, and design thinking. And she probably wouldn't want me saying this, but from her awards during her studies, it's obvious that Catriona is an outstanding student herself. So I'm really looking forward to hearing Catriona translate how we can bring the wonderful world of AI and ML to enrich the lives of students. So as Catriona's presenting, as I said, type in your questions in the QA box and we'll direct them afterwards. But Catriona, I'd like to welcome you to share your presentation.
Thank you very much for that lovely introduction, Sylvia, and thank you to Sylvia, Samantha and Data for Good for allowing me to present, inviting me to present this evening's webinar. So I'm going to put myself into presentation mode and get started. So the agenda for tonight is really to introduce machine learning and artificial intelligence as it looks in mostly a primary school context with some early high school, and to share my journey and really where it's brought me in my learning journey is to identify the importance of data collection in finding solutions to real world problems and how we can actually allow students to engage with those concepts. We'll take a look at some curriculum links, which is all important to teachers, and I'm going to walk you through some starter activities and demonstrations that have been tried and tested in various classrooms that I've been in. Now, with the activities, some of them, all of the activities could work as a standalone unit. So perhaps you're working on a digital technologies unit as a standalone, and you might want to run a whole term maybe or a semester on artificial intelligence and machine learning. Or perhaps you're looking at embedding this idea into an inquiry unit or perhaps an integrated STEM unit. So it's really a case of choose your own adventure. The idea is to bring a few samples of different things you might like to try. I've put in here the suggested resources, and I'm happy to share these with you at the end of the webinar. These are my really my go-to resources when I'm thinking about where I want to take my class and my students with artificial intelligence and machine learning. So I've got the Digital Technologies Hub. I'm going to share some of their ideas and lessons with you this evening. My Computer Brain, CESA Digital Technologies Education, Learn with Google AI, and the Hour of Code, Learn About AI. The reason I've chosen these to share with you this evening is because they're all free. They don't require any subscriptions, which is really important for teachers on budgets, and they can be accessed very easily on any device, whether it's an iPad, whether it's a Chromebook, and none of them require any downloads. So I've kept it so that everything is accessible to anybody who might like to try them. To give you an idea of what a semester in STEM looked like when we were purely exploring artificial intelligence and machine learning, these are some of the topics. So I'll be taking a dip into some of these over the course of this evening's webinar. So we began looking at machine learning. Part of what goes with that, of course, is AI and image recognition. We might look at computer vision and feature extraction. Classification is hugely important. Recommender systems, data collection and representation, and of course information transfer. So that would move on to data patterns and binary encoding. So I won't be touching on binary encoding this evening. We'll be looking more at the preliminary lessons in machine learning and artificial intelligence. You'll see here I've just highlighted the digital technology curriculum links so that for teachers it's all important to be able to map everything to the content descriptors. So I've put in at the bottom of the slide here, you'll see the different activities we're going to take a quick look at this evening and also how they map to curriculum. One note on this, that many of the activities we look at are equally applicable to the Year 3-4 levels, and many of them as well to Year 7, very early high school. Now, it does depend, I know with COVID, certainly a lot of the digital technologies curriculum perhaps was difficult to cover. So you may find that you're going a bit further back or a bit further on with some of the activities. So as you're looking at them later, you'll be able to come back and map them to the actual curriculum. So we normally start with, even with the students, when we begin introducing artificial intelligence, it's always important to make connections for students so that all the learning has purpose. So we're making connections as well and links to industry, careers and future learning. So that's really important to inspire students where they might like to take this learning into their own future careers and lives. There are multiple opportunities to link to integrated inquiry or perhaps STEM with anything related to artificial intelligence. And we're looking as well to make connections and authentic links to student experiences. Now, when we're talking to students about how AI is important and why it matters and how it matters in primary school, we need to look at, well, how is it impacting our lives? How is it in use? Everything from our smartphones to our social media platforms to how every time we go to the supermarket, they've now got these cameras that are watching everything, collecting data, self-driving cars, autonomous vehicles, security and surveillance, your smart home, navigation. So as soon as sat nav goes on, as soon as you ask Siri to find you something, all of these are using artificial intelligence and machine learning. So there's multiple examples of AI in real life. And when we're looking at beginning AI and machine learning with students, that could be a whole session, just identifying where it's used, how it's used, where we think it's used. And the next really important part for when we're looking at the sort of this area in digital technologies is, of course, the area of data. And data is part of every single step in computational thinking. So I'll share with you this little image here that shows you the different areas of computational thinking. There's also huge connections to mathematics curriculum. There's specifically pattern recognition is a big area that you'll see where we're analyzing data. Students are looking for patterns, how we make sense of that data. Of course, decomposition, breaking problems into parts. We've got abstraction, algorithms, again, evaluation and modeling and simulation. So we're going to look at a few examples of how you can actually use modeling and simulation in classes. But when you're teaching AI and ML in a classroom, you are very much focused on computational thinking and data. So I'm going to start off by sharing, this is a video that you might like to share with students if you were actually going to introduce AI and ML to them. So I'll share this video with you because I think it's worthwhile actually experiencing what the students might experience. And I'm just going to flip my screen for a second and we'll just have a quick look at this short introduction.
When we look at the world around us, we often see things that are similar, but rarely identical. This feature of the world makes it interesting for us, but poses a challenge for computers. For example, let's try to teach a computer to recognize trees. You might think, how hard can it be? It's a very easy task for our human brains, and every child can tell a tree from a stop sign. But let's ask ourselves, what makes a tree a tree? After all, we hardly ever think about it. But there are all sorts of different trees, of different colours and different shapes. The trees here all look different in size, shape and colour, but they are all trees. So if we want to describe a tree to a computer, we need to be very specific for the computer to understand. We could start with trees have green leaves, trees are tall, and trees have brown trunks. But what about this tree? It has green leaves, but also has yellow flowers. It's tall, but it has a grey trunk. So we need to refine our criteria to include this tree. But this can lead to our description matching with other objects. Computer scientists found that it's really hard to be explicit and specific, yet inclusive enough to describe every tree in the world in a way that the computer can make sense out of it. So instead, they thought, let's just show the computer lots of examples of trees and let the computer make sense out of them. This was called machine learning, and it was a groundbreaking new idea. Or not, because when you think about it, this is really the way we humans learn. So the scientists had a good look at how our brains operate, and they came up with models that they could implement as computer programs. They called this artificial intelligence, or AI. So an AI is a program written by computer scientists that can learn and, based on the feedback it receives, make adjustments. Just like the way students learn at school, where they receive valuable feedback from their teachers and improve their thinking.
Okay, so I find that's a really simple way to explain what AI and ML is as an introductory video. So really, artificial intelligence in a nutshell, it makes machines seem intelligent. And it makes them seem intelligent because they're moving up. We as individuals are moving on from writing a program telling a computer how to solve a problem to writing a program that allows the computer to learn to solve the problem by itself. And machine learning is a way in which we do this, is how we achieve AI. But for machine learning requires access to data. It analyzes trends and then produces insights. So we provide machines and programs with lots of data. It sort of really is a form of demonstration. And from that, the machine learns and adapts, much like the way the human brain works. So we're going to have a quick look at some machine learning examples, and I'm going to take you through one activity called the teachable machine. Now, the teachable machine is an example of how we can train a machine to understand using a camera. We're effectively training what's called a neural network that's hidden on the device. And the neural network consists of an input. It consists of an input layer, it has classes, and it has an output layer. So we're going to take a quick look at the teachable machine, and I'm going to use the example from here. And it walks us through the short tutorial, which we'll do together. So let's go.
This is an experiment that lets you explore how machine learning works. You can teach the machine using your camera and make it respond to you in fun ways. Okay. Over here is your input. You should see yourself. Over here are 3 classes, green, purple, and orange. And over here is the output where the machine responds. Right now it's set to respond with one of these 3 GIFs, but you can also make it respond with sounds or speech. Okay, so first we're going to teach it to respond with the cat GIF when you do something. So do something like put up your hand, kind of like this, and hold this green button for a couple seconds. Okay, you should now see the green bar and the cat GIF. But if you move around like this, you'll see that they're always showing no matter what. That's because the machine is looking at your input and picking which class it looks most similar to. But since you've only trained the green class, it always picks that one. That's why you need to teach it a second class. So now, just sit there with your hand down like this and hold this purple button for a couple seconds. Okay, now it should work. Move your hand up and down like this, and you should see the cat GIF when your hand's up and the dog GIF when it's down. Go ahead and try it. Great, looks like it's working. The orange button works the same way as the other classes. And these X's are for resetting any of your classes to teach them something new. And finally, be sure to try the other outputs over here. And now just start playing around. Teach your machine whatever you want. And if you scroll down this page, you'll find some ideas for things to try and links to learn more about how all of this works.
The teachable machine is really popular with the students when this is done as an activity, and they choose all different outputs. So they'll use different sounds, they'll use different speech, they'll use the classes for the machine to respond to different things. But ultimately the machine is learning, it's learning to recognize the input. So the input in that activity is whether it's my hand movement, it's what I'm doing, what my body is doing, and it's trained to respond, and it responds with a certain degree of confidence. So if my hand is a little bit half up, it's not quite as sure because it's seeing 2 possibilities. So it's not quite sure until I've either got my hand straight up, my hand straight in front of my face, or my hand straight down. Then it responds with much more confidence. So that is, like I say, hugely popular with the students. They have endless fun training that teachable machine. Now I'm going to come back into the slideshow again. There is another activity here which I've got linked in the slide to a Google Semantics game. That's a word association game, with machine learning. So that's another one that you might like to try as well. Of course, image recognition is a hugely important part of AI, and I see my slides are having a little think, so we'll just give them a moment to load again. So for a computer to recognize images, it requires three things. It requires data, so it's an input of data. It requires classification, and then there's processing. So I've given you a little outline, and you can see from this image of the little doggy here in the picture that only 2 classes have been trained. So there's been a class trained for dogs, so this machine would have been trained with many images of dogs. There's also been a class trained with cats, so multiple images of cats. And when the machine sees this, or the AI sees this image, it recognizes it as a dog as opposed to a cat. Now, it doesn't look at, say, the duck in the picture or the little windmill spinner thing, because it hasn't been trained for those classes. So it's limited to the information and the data that it actually has. Over here, you can see it's been trained in 4 separate classes. So we've got a dog, we've got a cat, we've got a plane, and we've got a duck. So when it sees the image now, it's not incorrect. It's seeing a dog and it's seeing a duck. As to why it's seeing a cat, not quite sure. Maybe there's some cats similar to dogs images. And the plane, when we discuss this with the students in the class, they figure that maybe the little ear and the dog look like it could be a plane in the distance in the sky. So that might be why the plane comes up as a faint possibility. The cat, again, is a faint possibility, but it's certain that it sees a dog and a duck. So image recognition has many applications in artificial intelligence, and we can see here that we need input of data, usually through a camera. It requires processing, classification, just like we did with a teachable machine, where we're waving, we're training classes, where we looked at the image of the dogs and we're training the number of classes. And it's based on how we group data on attributes and features. So it's up to the human beings to label those classes and decide what data input is going to go into the machine. The machine then matches future data. This is how it makes predictions based on the similarity of new data. So for example, the image of a new dog in the previous picture compared to the predefined groups, or compared to the images that are already there. So sorting images of kangaroos and wombats based on their number of legs, whether they have a tail, whether they have external ears. So any features really that the machine can be trained with. When we're looking at how an AI can recognize what it sees, we're also thinking about that in the context of how that technology is used in the real world. So another thing I like to do in the early stages of AI and ML is for the students to just explore how it's being used in the world and how that applies to what we're learning in school. So I've got some examples here of some links, which I'm not going to open up now, but it's an example of the kind of links for example, of computer vision that you might like to search in relation to perhaps as a STEM unit or an inquiry unit that you're conducting. So one here we have, how might an AI tell a shark from a dolphin? How might an AI distinguish a crocodile from a fallen tree branch? How does an AI in a drone know a weed from a wetland plant? And it's AI and that importance of capturing data and classification is hugely important when we're thinking about things like conservation, we're thinking about things like the environment. So perhaps you're doing a unit related to the United Nations goals. Monitoring land is one of the goals for the United Nations, and drone technology and that technology in use is hugely important, because being able to capture data and capture information is what allows us to ultimately make informed decisions. We cannot make informed decisions. We cannot put in place preventative measures without data and without data being collected. You can also look at self-driving cars. So the technology that's in those, how does a car tell the difference between a traffic light and a tree? And in that early introductory video we had, what is AI and ML, that gave us a little example there of just how important it is for the AI to be able to do that, so that every time it sees a tree, it doesn't stop. I think it needs to stop. Cutting edge conservation, as I mentioned. So how does technology help to prevent the degradation of land? Drone technology is being used and data information a lot by the farming communities, and for monitoring crops. It's being used a lot in, if you're particularly in the senior school, if you're looking at the topics of environment and extreme weather, and we're looking at bushfires. How do drones and how does technology help us either respond appropriately to a bushfire, to know what's happening after a bushfire, and also to monitor land after those events so that we can prevent things happening. And more it's being used using drone technology, but behind that is the machine learning, and behind machine learning it's all that data. So it's gathering that data, it's processing it. So these are all great opportunities to provide context and to also for students to really connect with just how important data is. Now, this was an example of a unit that I did earlier on in the year, and it was around aviation conservation and the UN goals, and it was in the context of the UN Decade in Restoration. We were using Tello EDU apps to simulate and to prototype and going into a disaster zone after a natural disaster. And again, finding the links to the UN goals, finding real links in real media, newspapers, magazines, so that students can connect what they're doing to the real world. It also is a great opportunity for students to see the kind of jobs that are there and to hopefully inspire some future careers. Now, as I've mentioned, the importance of classification and the importance of feature extraction really sits behind all AI and ML. So one thing we can look at, not everything has to be plugged either. So by that, I mean, not everything requires a device. A lot of the activities, particularly around data capture and understanding that, can be done unplugged. So feature extraction is one really good one to do unplugged. There are some fabulous resources for this very topic on the Digital Technologies Hub, and I've put a link into the slides to take you directly to those. That really begins in grade 3-4. So if you haven't had a chance to do that kind of work on feature extraction and classification, then that's where you will find some amazing units on that. So of course, one way an object or an AI recognizes an object is through feature extraction. So there's object detection and classification, and there's features that differentiate one object from another. So if we look here at the bird and we look at the cat, we're looking at their specific features. And so the machine will be trained with multiple images of birds, multiple images of cats, but also it'll be sorted by the classes, by their legs, by their feathers, by their beaks, or whatever their specific features are. So we're then into the if-then, we're into the if the animal has feathers, then it goes into group A. And this is where we start to look at all the algorithmic language of branching. An example of what you might do is for students to describe features of different animals to enable the AI to recognize one object for the other. So it really gets the students thinking about not just, oh, is it a koala or is it a dog or is it a cat, but actually thinking about, well, what is specific to these animals? What does the machine need to know specifically? So how do we compare a shark to a dolphin? How are they similar? How are they different? Looking at a crocodile in a tree branch, comparing a weed in a wetland plant, and even a traffic light in a tree. And that's an activity where students come up and they identify the different features. Again, it's all unplugged. And moving on from that, this is again a very popular activity, is using the features. How might you represent them in a simple line drawing? So I'm going to share with you now an experiment which has a habit of going horribly wrong sometimes because I'm not known for my drawing skills, but we'll give it a go. So we're going to go to Auto Draw by Google, and we're going to draw, I'm just going to show you the demo for this. We're going to do an Auto Draw as one, but we're going to go to Quick Draw, and I'll explain to you how this works. So this again is it's a neural network, and it's how can we train a neural network to learn to recognize doodling. So we're going to train this neural network. Now we're going to add to this. This is actually one of the largest data sets in the doodling data sets in the world. It's shared publicly, it's free, anybody can use it. And what it does is it collects millions and millions and millions of drawings from all over the world, from all different people, and it uses all that learning, that ongoing learning, to make predictions about what you're drawing. So the activity goes like this. It asks you to draw something, and it gives me a number of objects, and I've got to draw them in under 20 seconds. Now, there's only a couple of minutes to do this, so it's pretty quick. So yeah, ignore the drawing. Okay, so I've got to draw a hammer, so I'm going to draw my hammer, and oh goodness me, it stopped. Oh, it's having a think.
I see line, or toothbrush, or belt, or marker. I see clarinet, or sword, or trombone, or dumbbell.
Nope.
I see the Great Wall of China. I'm not sure what that is. Sorry.
Oh my goodness,
I couldn't guess
raccoon.
it.
Okay, got it, raccoon. How on earth do we draw a
I
raccoon?
see circle, or moon, or potato, or eyeglasses. or sleeping bag. I see toothpaste.
See,
or
this is why when
trombone,
you do
or
this with
egg,
the
or
students, it's
dog.
very
I see
interesting.
sheep, or cow, or tiger, or black cat, or horse. I see cat, or mosquito, or squirrel.
Okay, next.
Sorry, I couldn't guess it.
Okay, microwave. Let's have a go with the
I
microwave.
see bench, or springboard, or pillow, or square. I see suitcase.
Here we go
Oh,
with the
I know.
microwave.
It's microwave
Oh,
oven.
yay! Umbrella. Okay, let's have a go with the umbrella.
I see nose, or golf club, or foot, or hockey stick. I see leg, or sock, or knee. Oh, I know. It's umbrella.
Oh my goodness, you're kidding me. Trombone. Okay, let's go with the trombone.
I see nose. I see potato. I see steak, or watermelon, or shoe, or hockey puck. Oh, I know. It's trombone.
Yay! Okay, and a feather. All right. So we're drawing the
I see
feather.
line, or garden hose, or arm, or elbow, or nose. I see stitches, or stairs, or tree. Oh, I know. It's feather.
All right, so what happens is when you've had your attempts at drawing, what the machine has asked you to draw, it'll tell you, it'll say, right, we figured out 4 of your doodles, but it saw something else in the other 2. So I'm going to show you an example of how it works. So when I click on my microwave oven, it tells me that you drew this and the neural net recognized it, but it also thought there were similarities to other objects that it might be. So it could have been a picture frame, could have been a postcard. And then how does it know what a microwave oven looks like? So it learned by looking at these examples drawn by other people. So you can see the multiple examples, and my amazing drawing, which I've just done now, of course, is now part of these multiple examples that will be used for future. So the students are able to see just how what they've put in connects to other data and other images that the machine has already been trained with. And when I go back here, so you can do that for each of them, but when I go back to here, just to give you an idea of how this works a little bit more, we can really look at the data and see what 50 million drawings. That's a lot of learning, that's a lot of data, and they've played quick draw. So what you can do is you can look at any object, and if you want to see, all right, so this is a chair, so what things have people drawn on the internet that look like a chair? And these are all the different attempts at drawing a chair. So what happens is the machine's learning. So as you begin to draw the chair, it's matching what you're doing. It's matching that data you're inputting to what it's already learned, and it's making a prediction. And that's what it's doing, and it's on identifying the object. So you can spend some time on quick draw exploring all sorts of different things. We're looking at a bear, you can look at a bear. We can again see all the data that's been input by people as to what a bear looks like. I'm not sure what a raccoon looks like. I'm not going to even look at that one because that was a bit of a disaster. So that's the the quick draw. That's a really nice activity to do. And you'll see here, I've put in, just for reference, I've put in the quick draw and some examples of dog drawings, for example. So if you're asked to draw a dog, you could start with anything. You could start with this really simple shape. You might only get half the body. Even here we have the body and the tail, but the machine has learned enough to make a prediction that that is highly likely that that is actually a dog. So these are examples of ones I did earlier, just for reference to remind you in case you want to do that activity. Now, the other thing I want to share with you really quickly tonight is recommender systems. Artificial intelligence is part of so many user interfaces, and machine learning can curate, it can advise, it can orchestrate, and it can basically push things out to you based on what it has already learned. So anybody who watches Netflix or subscribes to any of these things will already know that as soon as you turn on Netflix, it recommends something to you based on some form of system. It'll either be based on one of 2 things. It will either be based on things that are similar to programs that you've already watched, so features in those programs, or it'll be based on preferences similar to other users. So we're going to look at the 2 different ways recommender systems work. How do apps suggest what you might want to watch, buy, or listen to? This is also really nice connection to make with cyber safety. And we used to talk a lot about digital footprint in terms of cyber safety and understanding what data is captured. So that idea that everything we choose, everything we select, we are training machines, we are feeding into algorithms that then make recommendations to us based on our behaviors and our actions. And through that, the algorithms actually control a lot of what we do and control a lot of what we see. So I'm going to look first. Again, this is an unplugged activity that I've done. It as an unplugged activity, and it's content filtering. So the content filtering system, how that works is you'll see here there's 4 different movies. So I'm going to the movies and I'm going to go and see Inside Out because that's what I really like. And it turns out I really like Inside Out. And I'm thinking about the features. So I'm looking first at a list of qualities or features that I consider important. So when I'm choosing my next movie, I want movies that are going to be similar to Inside Out. So I'm going to think what features are important to me. So is it animated? Is it a Marvel movie? Does it have a supervillain? Does it pass the Bechdel test? Or does it have a Parks and Rec alumni in it? Just random thing to put in their features. So when I look at Inside Out, I can see that it's got, there's a Boolean term, so a yes or no, yes, no, no, pass, or yes for the different features. And when I look at Minions, I can see that that's all being completed as well. So is it animated? And I populate that table based on the features. And when I'm trying to decide and compare data, so this is again, mathematics, creating tables, comparing data, I'm wanting to compare, if I really like Inside Out and it's got those features, then what other movie of these 3 that I could go and see has the most similarities, so that might be the most appropriate for me. So if I compare Inside Out to Minions, I can see I would give that 1 point because they're both yeses. If I look at Marvel, I would also give that 1 point because they're both no. So the values are actually the same. If I look at, does it have a super villain? Those values are different. So there's no point there. If I look at the Bechdel test, one's a pass, one's a fail. There's no point there. And if I look at the final feature, I can see that they've both got yeses. So because we've got, this is the same 1 point, this is the same, and this is the same, I can score that with 3 points. So based on the features and based on the content of the movies themselves, I am most likely to want to go at the moment and see Minions when I've done the same process with the other 2 movies. The point system works out that compared to Avengers, there was only 1 point, and compared to Ant-Man, there was only 1 point. Now, if you're doing an activity like this, it does take a little bit of getting your head around, so I would suggest that you look at these slides and see again, remind yourself, perhaps play back this bit of the webinar just for exactly how this works, because it can be a little bit sort of confusing. So you're basically building a table listing the properties and you're scoring similarities. And it's based on those similarities that you will make a recommendation. The other way that filtering and recommender systems work is with collaborative filtering. Now, collaborative filtering is based on preferences of other users. So we're not looking at the movies themselves. The movies and the qualities and the features of the movies have no bearing on this whatsoever. This is purely based on user preferences. So I might go and survey my friends. So in the classroom, I might choose movies, and I might go and survey all my friends, and I might ask them, do they like it? Yes, no. So this is again, simple Boolean terms, yes, no. And then I might have myself at the end, the name here is in SCAS, and I'm asking myself, all right, so if I liked Inside Out, what other movies might I actually like to go and see? So I want to then look at the users here, Jason, Andy, Sarah, Sam, and Skaz. Jason liked everything. I mean, there's always somebody who likes everything. Jason liked everything. So I'm going to include, because I liked Inside Out, and so did Jason. Andy didn't like Inside Out, so I'm not actually going to consider that data at all. Sarah liked Inside Out, so I'm going to consider her other responses. So the only responses I'm actually going to look at are the responses from Jason, Sarah, and myself. That's it. So when I look, did Jason like Minions? Yes, he did. Did Sarah? No. So that's got 1 vote. Did Jason like Avengers? Yes. Did Sarah? Yes. 2 votes. Did Jason? Yes. Did Sarah? No. 1 vote. So based on the collaborative filtering system, I'm most likely to have Avengers recommended to me. Again, nothing to do with the similarities between the movies themselves, purely based on user preferences. So I've given you a little bullet point there of how that might look. So this was a template that I just made in a Google Doc, and I just put in some things that the students use or may be familiar with, sort of to give them ideas. And they could build an unplugged recommender system based on movies, based on music, based on food, based on games, whatever they choose. So I'll show you some work samples that we've collected. Now, I haven't shown you any collaborative ones because they've got student names on them, but here you can see some recommender systems. This is where students then use the data. They write informed statements, they collect, they compare, they contrast, they predict, they recommend. This one here, they chose social media platforms, and the features they identify are whatever they consider important. So there's no right or wrong with this. It's really down to whatever the user who's creating this deems important. So they had like privacy settings. Does it have a messaging system? Can you become famous? Does it have a 13+ age limit? Another example here, you can see there's a few games being compared, same sort of thing. The criteria they had. Does it have different game choices? Non-problematic. Obviously, there was somebody felt very strongly about that one there. Is it popular? Is it creative? And do you need skill? So based on these criteria and based on the yes/no responses, students can again write the informed statements based on the data that they've collected from surveying the rest of their class. So that's a really a simple, straightforward introduction to recommender systems, again, really connecting to the technology that students are using in their daily lives. The other thing that we saw earlier on was when, in particularly in the introductory video, was that idea of neural networks in artificial intelligence, that idea that machines and AI can appear clever, sort of similar to how the brain works. So I'm going to show you some simulators for neural networks. I have links to these as well, which I'll share all of them with you. But I just want to show you a couple of them. This is how an AI to identify animals by features might work. So you can see how important data and classification is. So here the features that have been used are, does it have legs? Does it have wings? Does it have fins? And again, what sits behind this is a spreadsheet that students could populate with Boolean terms, so your yes, no. And the machine will be trained, and this is where all the magic happens. This is the middle layer. I can't explain that personally. And then the output will be the prediction. So if it has fins, if it has tail, if it has skin, and if it has scales, the machine predicts that it is going to be a fish. So that's a simple graphic explanation of how you might use an AI to identify animals by features. The anti-bullying cyber safety, which I mentioned earlier, there was a task that I'll share with you now that we did, which was exploring artificial neural networks by training a network to distinguish between nice things and mean things in posts. And the students with this one had the idea that they could use it for anti-bullying, in the sense that if you had a mobile phone device, obviously there's a lot of messages being typed by a lot of students, that what would happen if you were able to train a machine to put a pop-up up. So if you're typing what the machine deemed to be a mean phrase, it might pop up something like, these words may be mean, are you sure you want to hit send? So that idea that a machine can help humans make better decisions, or just allow you to stop and pause before you take action. It's not perfect, obviously, but this was an idea that we explored. So we trained an AI to identify kind things and mean things. And then we tried it out with different phrases. So again, these were all the words. So we had the kind things, 2 classes. We had kind things and we had mean things. And the kind things had phrases like, I like you, your hair looks nice, you have a great smile. Mean things, I hate you, that's dumb, your hair looks terrible. So we put all of those things in. So that obviously needs a bit of moderating in the actual classroom, but generally the students do quite well with this. So all of those terms go in. We train the machine. It's a really cool thing to do. We actually sort of hit train machine, and the machine does all this fancy, you can see the neural network being trained. And then it's ready to go. So we type text as if we were typing a message into a phone or into a social media platform, and it will identify from the words and the phrases that we've used, will attempt to identify whether it's mean things or whether it's potentially a kind thing that we are saying. So you can see here, your hair looks nice. You don't have to type these sentences exactly as they're written there. It can be different. The machine's clever enough that it can just isolate those words as part of a larger sentence or a bigger phrase. And here you can see it's identifying, oh, they're kind things. So that was how the anti-bullying AI worked. The final thing, and I know this is a really whiz-bang tour, the final thing I wanted to share with you tonight was the the Minecraft Hour of Code. Now, the Minecraft Hour of Code, this is the only resource I'm sharing with you that does require a subscription to Minecraft. So if you have access to Minecraft EDU, then this is a really nice one again, and using AI for good, as Sylvia mentioned earlier, that's the whole purpose of this, is making a difference. It's how we can use data for good. It's how we can use data for, you know, to improve our world, really. So this activity, basically, it's all about, it gives students sort of a high level understanding of how artificial intelligence can be used to collect data about forest fires. So they basically create coding solutions that include sequences, events, loops, and conditionals. So a large part of that is decomposing, as we spoke about that computational thinking earlier on. So decomposing the steps needed to solve problems into precise sequence of instructions, and it also allows students to iterate on solutions and to complete the task. So I've said that does require the Minecraft Education Edition, and that there's a little overview. A village is threatened by fire and you need to code a solution. So with your Minecraft agent, you're going to navigate the forest and you're going to collect data. That data will be used to help the agent predict where the fires will occur. And this links really nicely with how we prevent, you know, when we're looking at natural disasters, how we can actually use AI to sort of prevent damage. And then we code the agent to help prevent the spread of fires, save the village, and bring life back into the forest. So it's learning the basics of coding, it's exploring AI and ML with real world examples of artificial intelligence. So that's all the examples that I have to share with you for tonight. Hopefully some of that made sense, and I will, yeah, I'll come back into the webinar where I was. Okay.
Catriona, I can't think of a better way to teach than using cat and dog gifts. Like,
Oh, it all starts with the cats and dogs. Yeah.
Yeah. And it's clear that technology has moved along a long way from me telling an apple to jump.
Yeah.
So we're grateful for the time you spent to find the best and most fun resources. And when you were doing your quick draw, it did say squirrel for the raccoon, so I thought that was quite close. And I nearly cheered when it got umbrella. It's like, yeah.
Oh, look, it's a bit embarrassing doing that as a sort of in a context like this, but never mind.
Yeah. So a couple of questions just coming through. The students, when they're filling in their recommender system templates,
Yep.
It reflects that it's highly opinion based. Obviously there's likes and dislikes, but some of them things like non-problematic or problematic.
Yep.
That's a little bit more while there's an opinion to it, there's also a truth or not truth factor.
Exactly. And the lesson there is that any AI and any machine learning, it's only as good as the data we give it, and it is subject to bias, and it is subject to opinions, and this is where we're learning about bias in systems and bias in technology. So that's a really important lesson to sort of convey to students, that there is a huge amount of bias, because AI will only do what we tell it to do. It will only respond to the data that we train it with.
Yeah. And I guess that reflects, it reflects real world situations as well.
Absolutely.
And the bigger your training set, the more accurate you're going to get.
Yeah. Teaches you to question. Yeah.
Yes, exactly. Question and challenge.
Yes, indeed. Yeah.
Yeah. So how can a computer, so with the example, you had a dog with the sunglasses sitting next to a rubber duck. So the dog's real, the rubber duck's not real.
Yeah.
Is that once again coming down to your training sets?
That's coming down to your training, and AI can't tell. It really, it's fairly primitive, and we obviously, as we went further into that, we looked at how a computer recognizes what it sees, or an AI. And if I would suggest, if you're looking at exploring that a little bit more, that you go onto the Digital Technologies Hub to that, how a computer recognizes what it sees, because what it's doing, it's actually breaking down the object into shapes. So it's not recognizing it as being alive or being inanimate. That's not what it sees. It literally recognizes it as shapes. So am I sharing still? Can you see my machine? That
not
image
at the
there
moment.
with oh, here, I'll just go into this one. I'm just going to share. Look at this face here. It's not, machines don't see dogs or cats or people around. They don't see them as, they don't have the ability to do that unless we train them. So they're trained using shapes. So every object, every animal is broken down into shapes. So that's what it's seeing. It can't see that it's a rubber duck as opposed to a real duck. So it's probably, in that case, that machine has been trained with a whole load of images of rubber ducks, because it doesn't look very like a real life duck. So that's it's making a decision that that output is based on the data that it's been given.
Yeah. I love the mood lighting I've got now. It's like having to do a webinar at night. And being conscious, like teachers, they're spending all that like extra hours putting together, you know, what they're going to teach their students. They've got a lot of things they need to cover, wide range of things. Should all teachers be prepared to incorporate this level of computing into what they need to know going forward, or how can they balance that?
I know pre-service teachers now coming through actually have units that cover it, because the digital technologies curriculum is relatively new, and what you'll notice is that the maths curriculum as well has also been merged with a lot of the areas of digital technologies. So it is being merged more closely with maths, even in curriculum. They're looking at revising that again. But absolutely, it's on curriculum. And what I really wanted to try and get across tonight is that you can just dip into it and do little bits and still do it really well, especially if you put it into context of a bigger unit. So whether that's how life, you know, is monitored on land, whether it's technology is everywhere, data is everywhere, and there's been a lot of examples where I suppose students are just, they're using technology, but they're not creating it. So all the activities that I shared tonight were linked to try and give you an idea of how those relate to the digital technologies curriculum. But absolutely, it is expected that teachers can teach it, but the reality is that a lot of it just seemed, I think it used to have the impression that you had to be some sort of coding or programming genius, where you had to have particular skills to be able to start even delving into it. I didn't start like that. I started literally by going to the Digital Technologies Hub, and a lot of it was just teaching myself and thinking, well, how can I relate this to primary school students? How does it actually, where do I even start? So a lot of what I've shared tonight are the simple starter activities that you can do. And I would encourage anybody out there, just learn alongside the students. Don't worry if you can't do it. Don't worry if you don't completely understand it. Learn alongside the students. All the activities and the resources I've shared with you they'll all give you teacher background knowledge. They'll all talk you through things step by step. So the students are really quite adept. They're not afraid of this technology, and they're certainly not afraid of this learning. So I would just encourage anyone to just, you know, jump in, have a go, use some of the activities I've done tonight, even if you just want to do it as, oh, we're going to have a little bit of Digitech on a Friday afternoon and let's try some of these things out, just to engage. Just even start with that. That's absolutely fine. You start where you feel comfortable. But yes, it does have to be taught.
Yeah. And I mean, these are like games. These are really fun. Yeah.
Well, when we did the machine learning and the data classification, I actually got the students to code. We did it in a spreadsheet, because that's another thing. They need to be able to use spreadsheets and write formula. Even at grade 5, 6 level. So we got them to put in the spreadsheet the whole session of just data entry, and it was, does it have fins? Yes, no. Does it have legs? Yes, no. So they literally populated this table, and a couple of the kids said to me, oh, it's really boring. And I said, well, yeah, it is. That's data entry. That's what it looks like, but that's what sits behind all this flash technology. So it's just that realization and understanding that data is boring, but it makes the world go round, and this is how it's used, and it's absolutely essential.
Yeah. And that's what Phoebe, who did the our last Tassie Devil webinar, she spent days classifying different images
or things. Fun.
Yeah. It can be repetitive, but if you're learning alongside the kids as well, when you're teaching these, you know what the fail-safe thing is? Like, if you're struggling with something, just say it's a test in user interfaces. You just say, oh, we're seeing how well they've designed this product.
And that was connected to that slide that I showed you, where we had the neural network looking at, could it identify that or predict that it was a fish? So that was, the data was used with purpose as well. Yeah. So I think just whatever you're doing, if it's data, and you, of course, I mean, not everything in life's exciting. So yeah, you might have a boring session on data entry, but that was a really good lesson for the students. They had to learn how to use a spreadsheet. They had to do that data entry, and it really helps them understand. And some of the entries they put in were incorrect. So when they trained the machine, they're looking at it going, how can that be right? And then they had to go back and look at the spreadsheet, and they saw, oh, right, we put the wrong value in for that. So it's only as good as the data that you put into it. So it still is very much subject to human error.
Yeah, yeah. And it's a great way for them to learn as well.
Yeah, totally.
Yep. And I love that they're doing spreadsheets at that age. That's to me, that's classic.
Yeah, but they do
Yeah.
everything. I mean, look what they can navigate. It's just,
Yeah. Yeah. And
Yeah.
someone's asked, is there a way to contact you with questions, email, Twitter? I think we'll put a method to contact you in the newsletter that we send out.
Yeah, that's fine. I'm happy for you to put my work email out, and I'm on LinkedIn as well. So if you want to catch me there, and I've set the slides up so that I will actually share the whole slide set. And that's a starter. And you're welcome to use that. I'm more than happy to share. So I will share all the slides from tonight, and all the links are in there. And if there's anything you're not, just give it a go. It's not nearly as daunting as it might seem. And I know I threw a lot of information there tonight, but yeah, just pick one thing and think, oh, that looked interesting. I think my kids might like that, and just do that. Just do one thing.
Yeah, yeah. And I mean, the person who asked the question said it's all completely new, but I think it's all completely, like, it's doable too. It's fun.
It's very
achievable
doable
as well. Yeah.
It's very doable. And AI and ML and that whole, and particularly in that year 5, 6 level, it addresses every single aspect of digital technologies. And it's such a really rich context for doing that.
Yeah. Yeah. Just conscious of time, so I just wanted to get your final inspirational thoughts. So what would you say to inspire people to get them excited about teaching this to their kids?
Oh, look, I think that the students love it. The students are fascinated by it, and I guarantee you, whatever one of these activities, if you go with some of these starter activities, maybe not the spreadsheet, but whatever activity you put out, they will engage it, because that's their world. They're in this world already. We might not be, or might feel like we're not, but the students are already there. So in a way, we sort of need to catch up, and I think particularly in primary school. And the other reason it's so important is because the evidence says that by the end of primary school, so many students, they lose interest, particularly girls, in the sciences, and they think that all this technology and all this coding is just beyond them, especially if they think, I'm not good at maths. There's a lot of that. But the message we want to send to them is, this is for everybody. Everybody uses it. Everybody is capable. Whether you're a boy or girl, whether you're good at maths, not good at maths, it does not matter. And the students will absolutely engage. And if that inspires them to maybe engage with it in high school, well, I mean, that's really the aim of the game. It's to inspire more students to get into STEM, to get into technology, and for it just to be accessible to everybody. It doesn't have to be prohibitive. And I think there's a bit of a misconception that it is only for a certain type of mindset or a certain group of people. But technology and data and everything we've looked at today, it's for everyone.
Yeah, it's about problem solving and different
It
skills,
is.
and
It
everyone
is.
brings something different. Yeah,
Absolutely.
yeah,
Yeah.
yeah. Love to hear all that.
Yeah.
Well, fantastic. Thank you so much, Catriona, for sharing that with us
My
today. And
pleasure.
as I said, we'll send the notes out. We'll send the links to resources, and I'm sure before long everyone will be playing with those themselves, waving at the camera, seeing if the little cat's going to do its little movements.
Yeah, I look forward to it. Well, what I did tonight was like the demo you do in front of the class, and sometimes it goes a bit wrong and sometimes it goes okay. So
that's tech, right? That's tech for you.
absolutely. Yeah.
Fantastic. Well, thank you so much, Catriona, and thank you everyone for joining us. It's Thursday night. Enjoy your dinner. Enjoy going to play with your new AI resources, and we look forward to seeing you at the next Data for Good webinar. Thank you. Good night.
Fabulous. Good night.